to my YouTube channel, and in this video I'm going to revise with you a 2022 paper 1 science. And if you are new to this YouTube channel, make sure you subscribe even as we get to revise together. The good part about revision is that when you are revising, you are not only knowing how to answer these particular questions, but these questions should open your mind in answering another question. So these questions that we are going to revise with you, these questions should open your mind to know how you can answer other questions. So make sure you share this video with others. Let's make sure that we share with our friends. And if you are looking for tuitions, you can call me on my number, which is 0971 066747. 0971 066747. That's my number, or you can WhatsApp me on that line. So if you cannot see properly, you can try to make your screen big. You zoom it so that you are able to see properly. You make your screen big. Okay, you watch using a full screen, then you'll be able to see. It is saying answer all questions in this section. So this is how the question is saying. Write your answers in the space provided on this question paper. So the question is saying, figure B1.1 shows part of a micrometer screw gauge. So this is a micrometer screw gauge that you are given. First question is saying, what is the reading on the micrometer screw gauge? How do we get the reading? So what is important on a micrometer screw gauge? On this scale, is this last line here. This is the most important line. Have you seen? That is the most important line, that last line. It is what reading what? 20. Then you know that a micrometer screw gauge is measured in millimeters. Why? Because the accuracy, you may encounter such questions where you are told to find the accuracy of a micrometer screw gauge. So the accuracy of a micrometer screw gauge is 0.01 millimeters. This is the accuracy of a micrometer screw gauge. So meaning that is 20. So the reading there, it is what? It is 20. I'm going to put a 20. So I'm going to say it is what? It is 20. So I'll say 0.00 millimeters. This is what I'm going to do. Then I go to this other scale. So what is important to this other scale is a line, this line that is coming from the other scale here. This line here. This is the most important line. So you need to get the reading of that line. This line that comes there. So these are the only two important lines that you need to pick whenever you want to get any reading on a micrometer screw gauge. So these are the only important ones. So this one that is here, have you seen? This is a what? This is a 30. So you say, okay, 30. You say 30. You are going to get your 30. Multiply it with its accuracy. The accuracy is 0.01. So what do you get when you multiply that? So you say 30 multiplied by 0.01. What are you going to get? 0.3. We are going to get 0.3. So we're going to get 0.3. So 0.3 now is in what? Millimeters. Since I'm writing this to 2 decimal places, so I'm going to say this is what? 0 point what? 3. Then I put a 0 there. So this is in millimeters. Then I add. So when I add, what am I going to have? I'm going to have 20.30 millimeters. So this is the what? This is the reading on the instrument. This is a vernier caliper. This is a micrometer screw gauge. If you are given a vernier caliper, I'll make a video on that. I'll teach you how you can try to answer a question on that. So here the question was just telling us to know how to get the reading on the micrometer screw gauge. The other question is saying, state one use of a micrometer screw gauge. What does a micrometer screw gauge measure? So this one just measure the thickness of a paper. So they just measure thickness. It can be the thickness of a paper. It can be a paper, such things, small things. It can be a razor blade, those small tiny things. So this is how this instrument, this is how we use this instrument. So we've answered the first part. Here I've answered this question. This is 20.30 millimeters. We've answered that. So we move to question B2. So I'm just helping you with section B. Hope section B will really help you on how to go about other section B in different papers. So we move to the other part, which is this part here. This is the part that we are having. This is the part here. This is B2. Saying figure B2.1 shows an object first weighed in air and then when it was immersed in water. This is the question. Then we are given this diagram that is here. We are also given this diagram that is there. The first question is saying determine the weight of the stone in air. So we want to determine the weight of the stone. How can you determine the weight of the stone? So we want to determine the weight of the stone. So what is the weight of the stone here? This stone which is in air. So what we are going to do is this. This is what we are going to follow. I know that here, have you seen, it was starting from 0 here. It was increasing until it reaches this schist. So from 0 there until it reaches this schist. So that is the weight now, which is just what? Schist. So just say this is what? Schist newtons. You know that weight is measured in newtons. I move to the other question. So what is this question saying? The question is saying determine upthrust. So what is upthrust? How can you define upthrust? So I'm going to give you a simple definition of upthrust. Upthrust is a force. So is a force that pushes. So this is a force that pushes upwards on an object. That pushes upwards on an object. So that is object. That pushes upwards. So this is a force that pushes upwards on an object submerged. So submerged in a liquid. So when it is submerged in a liquid, it can be a liquid or a fluid. So this is upthrust. Upthrust is a force that pushes upwards on an object submerged in a liquid. So it can be a liquid or a fluid. This is what you need to know and understand. So when a question comes about upthrust, you're able to answer a question. You just say this is a force that pushes upwards on an object submerged in a what? In a liquid. It can be a liquid or a fluid. So it can be a liquid or a fluid. This is what you need to know and understand. So this question now, we move to this other question that is under upthrust. It is saying from the diagrams shown in figure B2.1, determine the upthrust of the water. So what is the upthrust of the water? Then I've told you that upthrust, this is a force that pushes upwards on an object So the object was what? The object here was at 60. So when it was put into water, the waters were able to push this object until it reaches what? The 20 mark there. So it was able to push it from 60 there down to 20. Have you seen? So the difference 20 here, and at first it was at 60. So when it was put into this fluid, or when it was put into this liquid, it went at 20. So from 60 to 20, what is the difference? So what is the difference? The difference there, that is your answer. So it was at 60. It moved to where? It moved to 20. So 60 minus 20, that is 40. Then this is a force. So it is what? 40 newtons. This is how you get to answer it. So you've answered that question just like that. We move to the other question here. We are given this question, which happens to be the last question on this part. What are we taught? The question is saying, calculate the mass of the stone. Take G, which is gravity, as 10 newtons per kg. So how can you go about this question? How can you answer this question? How can we answer it? So I'm going to show you the easiest way in which we can answer this question. I'm going to show you how you can go about this question, how you can answer it. So how can you answer such a question? So the way in which we are going to answer this question is very simple. First of all, you know this formula. So I'm going to write it here due to space. So you know the formula for weight. We say weight is equal to mass times gravity. This is the formula. Mass times gravity. Now we want to calculate the mass here. So I'm going to divide both sides by G. I divide both sides by G. So meaning G cancelled. I'm going to mean with the mass there. So mass is equal to weight over gravity. That is the what? That is the formula. So this is the formula now I'm going to use for mass. So mass is equal to weight over gravity, which is equal to, what is my weight? Weight was what? What was the weight of the stone? It was 60. So I say 60 newtons over. What is the gravity? What is the gravity? Gravity is 10. So 10 is 10 newtons per kg, like this. So finally, what is my answer when calculating the mass? This in 10 into 60, it is 6. So it is just 6 kg. This is how I get to answer it. So just like this, I'm done on this part. This is how I need to answer these questions. This is how I need to go about this question. So I've answered the first part. We move to the other part, which is B3. We move to B3. How can we answer a question? So this was just under that. Hope you are able to revise through. You are able to understand. So let us move to the other question. This is the other question that we are answering. This is the question. So I'm going to help you read if you're not able to see on top there. Figure B3.1 shows a device used to measure temperature. So this is a device used to measure what? To measure temperature. The first question is saying, define thermal expansion. So what is thermal expansion? This is the first question that is telling us about thermal expansion. So thermal expansion, we are going to say that this is the what? This is the increase. Thermal expansion is the increase. So increase in the size of matter. So increase in the size of matter in terms of area, volume. So in terms of area, volume, etc. So I'm going to do this. So this is what? Thermal expansion. What is thermal expansion? Thermal expansion is the increase in the size of matter in terms of area, volume, etc. This is what you need to get. So we've answered that part. I move to the next part here, which is saying identify the parts labeled E and F. So what do we call this part here? The first part E here, E. That is a bulb. So that is a what? That is a bulb. Just like that. Then what is a F there? The F there. That is a what? Constriction. So hope you are able to understand this. So the good part about revisions is that if you know that you don't have any idea on this matter, you make sure that you study about this so that you create your own time where you get to revise under thermometers. You talk of different types of thermometers that we have. You talk of those we've got different types of thermometers. So you study them, you know how to label them, you know how to differentiate them. So that's the good part about the revision. That's how we do effective revision. You must not only know how to answer this paper, but this paper should open your mind on how to answer another paper which is different to this. So I move to this question. Name a liquid that can be used in the device shown. So what liquid can be used here? This is mercury. So I'm going to say this is what? This is mercury. So this is mercury, just like that. Then the other question is, mention one way in which the sensitivity of the device shown can be improved. By using a large bulb. So whenever we use that large one, you discover that the sensitivity of this will be increased. That's how we get to increase the sensitivity on this object. That is what you need to know. Those are some of the terms that you need to understand. So I want to make sure that you understand this clearly, you understand this very well. We move to the other question. So like I've told you, if you're facing challenges on a question that I'm doing, just create time, revise through that question so that you find ways on how to go about them. I move to B4. So I move to B4. This is B4. So I move to B4. B4 is saying two successive crests of approaching water waves are separated by a distance of 1.8 meters. It takes 0.3 seconds for one crest to cover the distance of 1.8 meters. So here we are now talking about what? We are talking about waves. So this is a what? They are talking about crest, and it is only in a transverse wave where we get to find the crest. So if I draw a wave here, so if I was to draw a wave like this is a wave that I've drawn here. So between two successive crests, we are talking about the distance which is here and the distance which is there. This is what I'm talking about. So on this here, this distance, they're saying between two successive crests, the distance that is there is what? 1.8. So the distance from here to there, the distance which is here is what? 1.8 meters. That is the distance that is there between two successive crests. So then the other question is that it takes 0.3 seconds for one crest to cover the distance of 1.8. So to cover this distance of 1.8, so this distance of 1.8, it is the wavelength here. This is also wavelength. How do we define wavelength? Wavelength is a distance between two successive crests or it is the distance at which a wave repeats itself. So now here what we are given is what? 0.3 seconds. So this time which we are given here, this is called period time, because you know that under waves, how the way we get to define the period of a wave, the period of a wave is defined as the what? Time taken for a one complete wave. So this is a one complete wave. So this is period time. So what is period time is 0.3 seconds. This is the data that we are given. The first question, at what speed is the wave traveling? At what speed is the wave traveling? The formula for speed, speed is equal to what? Speed is equal to, so speed is equal to distance. Speed is always equal to distance over time. Have you seen? That is the formula that you need to use. So that's the formula that we need to know. Where I'm going to say that speed is equal to, what is my distance? My distance is 1.8 over, what is my time? My time is 0.3, which is equal to what? So when you divide there, what are you going to get? You say 1.8 divided by 0.3. What are we getting? We are getting a 6. So there we are getting a 6. This is a 6 which we are getting. The unit for speed, meters per seconds. So those are the units. Those are the units you need to get. Those are the units you need to understand. So let's make sure we understand that. So we move to this other question. It's saying, what distance is covered by the wave in 2 minutes? What distance is covered by the wave in 2 minutes? So what is the distance covered by this wave in 2 minutes? Now what's the formula? You know that when you go with this formula where you say speed is equal to distance over time, so meaning distance is equal to, you multiply these two, you just make d the subject of the formula, which is equal to speed over time. This is what you are going to do. So what is speed? So speed you already have, which is what? The speed you calculated, it is 6. So 6 times, what is your time? Time you're given, it is what? 2 minutes. So you know that 1 minute is what? 60 seconds. What about 2 minutes? 2 minutes is about 120 seconds. Just multiply this by 2. So 120 what? Seconds. So you say 120, which is equal to, so what is your distance? What will be your distance? You say 6 times 120. What are you getting? 720. You know the units for speed, meters. So this is what you need to do. So like this, you've answered this question. This is how you need to answer it. So this is how we need to go about this question. Let's make sure we revise through, we know how to go about all these calculations that I'm doing. So if you are not able to see, make sure the screen you are watching this using a full screen so that you are able to see these small words. So we move to the other part. We move to this question here. The question is saying, calculate the frequency of a sound wave with speed, this speed, and we've got a wavelength of that. So we only have one equation under waves that gets to summarize everything. So it's saying, calculate the frequency of a sound wave with speed 340 meters per second and wavelength 0.5 meters. So we only have one formula, which is velocity is equal to frequency times wavelength. So when we want to calculate for frequency, we divide both sides by wavelength, such that these two cancel out. Then you are going to have frequency, which is equal to velocity over wavelength. So frequency is equal to, what is your velocity? Your velocity is 340. What is your wavelength? 0.5. Then what is your answer there? What is your answer there? You say 340 divided by 0.5. What is your answer? What is your answer? 680. So I'm getting 680. So I say 680. Then what are the units is? Like this. These are the units. Then I'm done. I've calculated the what? The frequency. That's how I need to calculate frequency. I move to these last questions. This is the last question that is here. How can I go about this last question? So it is saying, would this sound with a frequency calculated in B1 be heard? The answer is yes. Have you seen? The answer is what? Yes. How now? How can this be heard? Justify your answer. So the simple one that you can go with, you just say because it is within the range, between the range of what? The range of 20 Hz to 20,000 Hz. 20,000 Hz, like this. Have you seen? You know that a person gets to hear sounds from 20 Hz to 20,000 Hz. This is the audible sound range. So the sound will still be heard because it is within this range. This is a simple definition that you can put out. This is how you can answer this question. So this is a simple simple reason, but we've got a lot of reasons that you can give. So if you know one, you can put that reason. We are not only limited to one way, one answer. Physics or science is very broad. It's not only limited to one answer. So this is not limited to one answer. It is broad like that. So we've answered this part. Hope you've understood. You know how to go about this question. So let us move to B5. We move to B5. Let us move to B5. We move to B5. This is B5. This is B5. This is an interesting topic that we all know how to answer it. This is an interesting topic. So what is this question saying? The question is saying infrared and radio waves are components of the electromagnetic spectrum. So this is also another topic called electromagnetic spectrum, where we get to find a lot of components that are found there. We've got microwaves, we've got gamma rays, we've got ultraviolet, we've got visible light, we've got infrared, we've got radio waves, we've got a lot of components that are found there. So you need to know in their increasing, you need to list them in their increasing wavelength or in their reducing frequency. So you need to know on that. So if you don't have any more information on that part, make sure you consider it. You start revising now. You study through it. This is an important topic and it always comes in an exam. So make sure you revise through it, you go through it so that you are able to answer one or two questions that may try to come in an exam. So we've got this question that we want to answer. So it is saying, mention one use of each of infrared radiation and radio waves. So one use of this one, one use of that one, we are going to say that this one here, it is used in communication. So communication. So I'll say communication in remote controls. We've got a lot of uses. So in remote controls, I'll just go with that one. But if you want, it can also be used in sensors like that. get to use it in that. It is used in different ways. We can use it in different ways. But when we go to radio waves, you know that these are the waves that helps us in communication. You discover that the radio is that side, the people are able to hear from here. So what is the use of those radio waves? They are used in what? In communication, conveying the information. So used in what? Mainly this is just used in communication. So just put communication there. It is mainly used in communication, conveying information from one place to the other. So this is how you need to do it. So here, the question here, mention one common property of infrared and radio waves. So when you're giving one common property, the property that we are following here, it is the property that all those electromagnetic components has. So they have got certain similarities in them. Number one similarity that you can put is that these ones, one similarity that you can go with is that they travel in a vacuum. So they do what? They travel in a vacuum. They travel in a vacuum. This is one reason that you can put. They travel in a what? In a vacuum space. So these travel in a vacuum. Then the other one which you can put is that they travel at the same speed. They move at the same speed. So the other one that you can also put is that they move. So these move at the same speed. At the same speed. Same speed. Which speed is that? The speed is what? 340. So the speed is 340 meters per second. They travel at that speed, at the same speed. Then we move to this one here, which is saying, give one arm of effects of electromagnetic waves. So they're just telling you about electromagnetic waves. So you can pick one from these. So these are what? Whenever we're talking about these electromagnetic waves, we've got a lot of them. They are found on a spectrum. So if you are able to know one, if you know the danger of an infrared, the danger of a gamma ray, the danger of ultraviolet, the danger of visible light, just need to put it here to make things very easy. So what you are going to do is that, you know, the simple one that we know is a gamma ray. So the danger of a gamma ray is that they causes what? Cancer. So just need to put here, they cause cancer. They cause what? They cause cancer. Just put it like this. They cause what? Cancer. Like this. You are done. So then you move to the other question, which is saying, give one difference in propagation between sound waves and electromagnetic waves. So keyword in what? In propagation. So in propagation, what is needed for sound to travel? So what is needed for sound to travel is that sound requires a medium. Sound requires so sound requires a medium propagation. So it's a medium propagation. Medium propagation. So say sound requires medium propagation. So medium requires a medium propagation, while electromagnetic waves do not. So while electromagnetic waves do not. This is your answer. So sound requires a medium propagation, while electromagnetic waves do not. And that's how you need to answer that question. Then they are telling you that mention one factor that affects the loudness of a sound wave. This is the word amplitude. Say amplitude of a wave. Amplitude of a wave. This is how you get to answer that question. So, you know what is amplitude? Amplitude is the maximum displacement of a wave from its resting position. So, this is a factor that will affect the loudness of a sound wave. Then we move to the other question. Let us move to the other question, which is D. We move to question D. Question D is saying, a learner sees a flash of lightning and hears the thunder after 4.5 seconds. How far is the lightning from the learner? So how far is the lightning from the learner? The take speed of sound in air to be 340. So how far? Distance. How do you calculate distance? You say distance is equal to, so have you seen, you are told to calculate what? You are told to calculate distance. So distance is equal to, you say speed times time. We are going to say this is equal to, what is your speed? Your speed is 340 times what is your time? 4.5. So this is equal to what? You just multiply like that. You just need to multiply. What answer you getting? 340 times 4.5. What is your answer? This is your answer, which is this answer. You say meters. Then you've answered this question. This is how you need to answer such a question. Then we move to the next question. So we move to the next question. This is the question that we are having, B6. So B6, how can you answer it? How can we answer B6? So it is showing figure B6.1 shows magnetic field lines between the poles of two magnets. Then first question, name point R. So the point R there, this is what? Neutral. So that's a neutral point. Have you seen? So that is a what? A neutral point. That's a neutral point. Then they're saying if P is a south pole. Have you seen? If P is a what? South pole. So if this P is a south pole, so if this is a south pole, meaning this one is a what? A north pole. Have you seen the way it is? Then the question is saying, so what is the question saying? So if this is the what? This is here we are given, this is the south pole. If P here is the south pole, so this is the south pole, then definitely this one will be a north pole. So since there is repulsion here, there is repulsion. So meaning that even the pole that is there, that is a what? That is a north pole. This is a north pole. This is a north pole. Then this is a south pole, like this. So the question is saying, what is Q and T? So Q, what is Q? North pole. So you say, this is what? Your north pole. So this S here was not showing that this is the south pole. No, these were just letters that were put there. Have you seen? PQR, PQST, like this. Have you seen they are following a certain order? PQRST. So this is not saying that it is the south pole. No. So since P is the south pole, point P here is the south pole, meaning this one is a north pole. Then since there is repulsion here, meaning this pole is also a north pole, north repulsion. So T is what? South pole. So say this is what? South pole. This is South Pole. This is how you get to answer this part. So we've answered this part. That's how you needed to answer that part. That's how you needed to do all the calculations that were involved there. We move to this question here. Move to this question that is here. This is a question that is falling under speed time graph. So falling under speed time graph. So it is saying figure B7.1 shows a graph of voltage against time when charging a phone battery. So when charging a phone battery, this is how the phone battery was being charged, like that. So then it was saying what was the voltage in the phone at the start of charging. What was the voltage? So when we started charging this phone, what was the voltage? Voltage is here. The voltage was 2. So you say it was what? 2 volts. It was 2 volts. Then the question is saying how long did it take for the phone to reach full charge? Full charge. Full charge. You check on your diagram. Full charge. Full charge. It reached at that. Don't know if you're able to see clearly, but it is that point there. That point there. Then here it stopped charging because it was completely full. So then you come down here. Come down with that. Come down with this. Come down with this. Until you get the reading that is there. Have you seen? Like that. So that is what? 3.1, 3.2, 3.4, 3.5, 6, 7, 8. So 1, 2, 3, 1, 2, 3, 4, 5, 8. So from here, don't know if you are able to see. So I'm trying to count these lines. So 1, 2, 3, 4. This is 4. 5 there. 6, 7, 8, 9. Okay. So that is for 3.4. So but if we were using a proper diagram where we are able to see, that is how you need to calculate that one. From there you come straight and get the reading there. So that is 3.4. 3.4. 3.4 hours. This is what you're going to do. 3.4 hours. Then what was the maximum charge voltage? What was the maximum charge voltage? So okay, the maximum charge voltage was here. This middle line. The line that is there, here. Then you get the reading from there. Have you seen? So 1, 2, 3, 4, 5. This is a middle line. So between 8 and 10, that is 9. Have you seen? Here. This, that is 9. So you just put what? 9. So you say that is 9 what? 9 volts. So that is what? 9 volts. So you are done now with this part. So we move to this one here. We move to this one here, which is saying, so what is this question saying? So if the working current of the phone is 0.6 amps, that is your current, calculate the charge accumulated by the phone in 2 hours. So they want you to calculate now the charge accumulated by the phone in 2 hours. How can you calculate the charge in 2 hours? So the charge in 2 hours. So you know that, okay, charge is equal to what? Charge is equal to current times time. This is how we get to calculate charge. Charge is equal to current times time, where we're going to say charge is equal to, what is your current? 0.6. So 0.6 times the time times the time. I want to say 0.6 times t, which is the time. So how do you do that? You say, okay, the time which is given is 2 hours. So you are given 2 hours. So you change now to seconds. How do you change to second? You say times 60 times 60. This is how we change from hours to seconds. So I'm showing you simple way of doing this. So if you multiply there, you're going to get 7 like this, 7,200 seconds. This is how we do. But if you want to change from seconds to hours, then you divide by 60, just like that. So if you 7,200 divide 60, again divide 60, have you seen? Like that. Then we find the answer to be 2 hours. This is how we get to answer questions. From hours to seconds, you say times 60 times 60. But from seconds to hours, you say divide by 60, divide by 60. That's how we get to find that answer. So that is what? 7,200. So charge is equal to, so when you multiply 0.6 times 7,200, that is what? 4,320 charge coulombs, like this. Then that is your answer. So always you need to be putting your answer there. This is where you need to be putting your answers. So if the working current of the phone is 0.6, calculate the charge accumulated by the phone in 2 hours. That's how you need to calculate it. We move to this question. We move to the last question on B7. It is saying we want to calculate the power of the phone when it was fully charged. Power is equal to what? The formula for power, how do we find power? Power is equal to voltage times current. So when it was fully charged, the voltage was what? 9. Here, when it was fully charged, we wrote 9 that is there. This is the 9 that we wrote here. So I just say 9 times the current I was given 0.6. So if I multiply here, what is the answer? 9 times 0.6. What is the answer? 5.4. So I'll say the answer is what? 5.4 watts. That is the power. That's how you need to calculate the power. So we've answered this part. We've answered this question. That's how you needed to do it. So the other thing now, if you remember here on this part here, so when it is the only part that you need to check clearly on your graph when you have this paper. So this the lines are too small. I'm not able to see clearly. So this one, the lines are, let me just put it can be like this. I'll just say O. It depends with the, but if you are using a graph, you are going to know this well. The same way I've explained here, where it is cutting there, that's where it is what? That's where it is fully charged. So when it is fully charged, then you come here, you get the reading, get like that. So when it is fully charged, you come get the reading. So here on this part here, if I check properly, though the lines are too small, but I would advise you to go with this one. So we can go with this one. We can go with this one. So go with this one, such that it is very easy to express this in a way where we say this is what 30, this is what 30 is, this is 3 hours. So 3 hours, this is 3 hours 30 minutes. Have you seen? 0.3 3.5 hours. So this is 3 hours 30 minutes. This is the time 3 hours 30 minutes half, so 3.5 half of minutes. This is 3 hours 30 minutes. So I would advise you to go with this one here. So that's how you need to calculate that one. But hope you understand. Just need to do some workings on your graph. Where it is ending, you come just like there. So that's how you need to do this. We move to the last question. This is our last question. So it is saying figure B8.1 shows a coil of insulated wire wound round a U-shaped core AB and connected to a battery to make an electromagnet. This is an electromagnet. So state the property of end A. So this is current is moving in this direction. So when it is moving in this direction, just know that the electrons, this is the north pole. Have you seen? This is the what? North pole. Because electromagnetic field move from north to south. So this is the easiest way in which you can know this. So that is your what? South pole. Just need to look at the direction, then you answer. This is the what? This is the north pole. Like that, you answer it. That is a north pole. You move to this question. Describe one way of increasing the strength of this electromagnet. One, by increasing the number of coil. Have you seen? By increasing the number of coil on the core. So by increasing, so just increasing the number, so increasing the number of, so just increasing the number of coil like this. The other reason is by increasing current. So once current is increased in the core, then we are going to have a strong, we are going to increase the strength of this electromagnet. So this is where we are going to end. So let's make sure we like the video, comment something. Thank you so much. So this paper, I believe it has opened your mind in answering another question. Thank you so much.